Hello, good morning. Welcome to fourth International Congress on Human-Computer Interaction, Optimization, and Robotic Applications. HORA 2022 is organized by National University, National Technical University, Kharkiv Polytechnic Institute. HORA 2022 is technically sponsored by IEEE Turkey section. Thank you for your scientific contribution and support to HORA 2022. If you want, let's start the session. First paper belongs to dear Marin Zilewski. Dear Marin Zilewski, are you ready to present? Okay. Dear Korhan Cengiz, are you ready to present? Dear Korhan Cengiz. Okay. Dear Ivailo Hardalov, dear Ivailo Hardalov, are you online?
Yes, hello.
Okay. If you are ready, you can start your presentation.
Okay, 1 second.
Hello, my name is Marin Zilewski.
Okay. Marin Zilewski,
Can you guys?
Okay.
Okay, can you guys see my screen now?
Dear Ivo Hardalov, you have 10 minutes, please.
Okay.
Okay.
So my project is on the cost of man in the machine in the 21st century. A little background. I worked in the United States in material handling, so distribution, warehouses, couriers, those types of things, and that partially inspired this project. So our main question was, for the starting point of this project was, is industry more sensitive to energy prices or labor prices? So that's a very broad question. But we decided to try to break it down and get some answers. So it's a trend we see everywhere. At supermarkets, we have automated checkouts, we have welding robots, we have sortation machines, we have all sorts of automation everywhere. So we try to break that down and see why that is. Then we try to look at some of the economics of that. So we look at countries with high labor costs, countries with low labor costs, and how that plays into it. And we also look at energy prices, since that also plays into it. So the first thing we decided to try to quantify was the human labor. That's very hard to compare to a machine, you know, how there's no unit of comparison for those. So the units we decided to use was kilowatt hours. So if we're looking at someone sorting boxes or doing just some mechanical labor, that seemed like a good starting point to be able to compare that to how much it would cost for a machine to do that same labor. So we did this in two countries, the United States in the state of Tennessee, and in Bulgaria. We found some estimates for roughly how many kilowatt hours of labor we can get from a person and roughly how much that would cost us. So then we started doing the same thing for machines. The nice thing was for machines, the energy costs were very similar within the countries. So they were within 5 or 10%, not nearly as big of a gap as the labor costs. So for this, we decided to standardize on 10 cents euros per kilowatt hour. This made all the calculations much easier. So looking at this, we get about 11,000 euros for energy costs for a machine that can do package sortation, very manual labor. So that seems kind of expensive for electricity, but once you realize that machine is running 2 shifts a week and potentially replacing 10, 20 people each shift, then it starts to make a whole lot of economic sense for why companies do this. So that's in the service industry. Package handlers, couriers, they don't really produce a product, so they don't have any material costs. So looking at something like car production, let's look at why we have that same situation there. So online, there are some estimates of what the breakdown of a new car, what the cost breakdown is. We find roughly about half of that is materials, which 22%, so almost a fifth or a quarter of the car is just the cost of steel. So we don't even see energy in the first rough estimates of a car. There's no energy, so obviously the cost must be low. Well, that's not quite the case, because with energy, we find that steel is very energy intensive to produce. So just the cost of steel is 15% energy. So once we include all the logistics, the overhead cost of all the energy that goes into the raw materials, we start finding that a vehicle does have some significant energy costs in its price. And a rough estimate puts that around 3 to 8%. And as we start getting into more advanced materials such as aluminum, which has a higher energy cost, and more semiconductors, that will tend to go up. Okay, so a car is something very large. What about looking at something very small that doesn't use as much material? So for this, we decided to look at an iPhone, because that's one of the most popular things. So data was more or less easier to come by than for other products. However, technology companies keep that data very private. However, looking at some estimates, we find that labor is estimated to be only 2% of the iPhone's cost. So that's almost insignificant. But then when we look more into it, we find that semiconductors, so the chips that make up the actual phone, that tends to be the vast majority of the cost, over half of the phone. And then digging deeper, we start to find that the semiconductors are very energy intensive to produce. So their price is vastly composed by energy. So what does this mean for economics? Well, trends currently are showing that unskilled jobs, so jobs that are very mechanical, not needing a lot of education, anything that can be learned within a day or two, they tend to be replaced by automation, because it just makes economic sense for companies to do that. And the pandemic, the unavailability of labor, the current economic situation has pushed a lot of companies to make that leap even faster, because when labor is unavailable and you have to adapt. So one of the other things we found was that energy requirements between different industries can be up to 152 times in scale. So the lowest energy industry uses 152 times less energy than the highest energy industry. And with this, we also looked at the same for labor, and the difference was only 3.3 times. So because of this, a lot of industries, it means that they have a very big strategic advantage to locate themselves where energy is cheap. So if they have a high energy requirement, then even a small percentage on energy cost will give them a big strategic advantage. So what can we conclude from this? Automation just makes economic sense for a lot of companies at the moment. Energy costs, when you look at an end product, you tend to not see them. However, they all trickle down into the raw materials, the processing, the mining, the initial steps where there is a lot of automated labor, such as, mining and the refining of metals. That's where they trickle down from, and transportation, all that overhead trickles down into the price of everything. And looking at how the pandemic has impacted all this, well, it's only pushed it to go faster. Companies see that. They see that it's a potential way to increase the effectiveness of their business, decrease costs, those things. So it's only been pushing it forward. And all this is fueled by the cheap energy prices. We have all this because energy is relatively cheap, and that's currently changing slowly. So that's one thing to keep in mind, is that energy trickles down into the price of everything, whether it be raw materials, logistics, processing, whatever it may be. So one of the things that we can look at in the future is start looking at what kind of jobs are created from this automation, because we may be displacing some jobs, but that also creates a new market for skilled labor in the development, maintenance, installation of all these systems. and look at the environmental impact. Is all this automation good for the environment compared to how we were doing things before? Is it worse? How can we make it sustainable in the future? And the other thing to look at is the stability of this whole system. So we become very dependent on energy, infrastructure, all these automation systems. So what happens in the events where those are disrupted? So cyber warfare, maybe a solar flare, some sort of climate issue, all these things, how resilient are we to those situations? So I'd like to thank everyone for your time. And if you have any questions, I'd be glad to hear.
Thank you for your presentation. Dear participants, do you have any question about this study? Okay, no question. Thank you again. I wish you success.
Thank you.
Thank you. Dear Marin Zilewski, are you ready to present?
Hello, thank you.
Okay. If you are ready, you can
Presentation.
present. You have 10 minutes, please.
Yes. Hello, my name is Marin Zilewski. I will present you a paper approach for implementation of vending machine through Verilog HDL. The vending machines are widely used in the modern world. They offer the opportunity to choose and purchase different types of products, like snacks, drinks, and others that can be placed inside or prepared on site by the machine itself for a fee. Payment at the vending machine is traditionally made by placing coins in a slot, but nowadays there are conversions that also use banknote and card placement. The main advantages of vending machine can be formulated as follows: provide the customer with the opportunity to make a free choice to purchase products at any time of day and year, a great variety of products that the vending machine can provide, a low cost due to lack of staff. The machine can always be moved to another location and will continue to deliver right products. This article focuses on a vending machine for coffee and hot drinks prepared at the moment, but develop control through the language hardware description, the description language Verilog HDL refers to a vending machine that offers 5 drinks that can be selected via buttons in the configuration 1-to-1. The way in which the payment is made in the machine is through coins. The maximum price of a product from the machine is limited to a certain value. Some simulation results are demonstrated and discussed. The hardware part is very important for the development of a vending machine, as it depends on many of the parameters and limits that must be complied with by the logic module. The vending machine consists of the next basic element: beverage selection buttons, 5 pieces, button to increase and decrease the amount of sugar, LED for white indication of the amount of sugar, model coin initialization, which is used for acceptance or rejections of coins, model storage and dispensing, like these models are used for the product like coffee, milk, sugar, and cocoa, respectively. Model hot water dispensing, dispense hot water in the mixer. Mixer is a device in which all concentrates are mixed and dilute with warm water. Device for dispensing coffee cups, and the model coin is used to dispense a single coin of the type. During the development of the control system, a modular architecture is applied, which allows the logic blocks to be implemented independently of each other. This gives opportunities for the improvement of each individual module without having to change the others one. The simplified block diagram of the implementing vending machine is shown in figure 1. Where the developed model for control are as follows: assortment, coin bank, input coin automation, select controller, buy controller, program selector, pricing. The coins are, to simplify the operation of the machine, are presented in tokens. The model assortment processes the information coming from the beverage selection button. The model pricing uses the incoming signal selection to determine the price of the selected beverage. The model coin bank is a memory model that stores the price values of each beverage. The model input coin automation is a fine state machine. The model buy controller is used to control and verify purchase, accepting the amount accumulated so far and the price of the drink. The model select controller accepts the value of a change that must be returned by the machine and controls the coins of the machine. The model program selector selects the correct program in case of a successful transaction and provides it to its output to be accessible by the program model. When activate signal execute enable is received the model program executor executes the following sequence: dispensing a cup, dispensing coffee, and others. In figure 2 is presented a control algorithm of the proposed vending machine based on the developed block diagram from figure 1. The developed models for control of the proposed vending system are successfully implemented in tests using the hardware language Verilog HDL. The next figure shows some of the results obtained. In figure 3 is presented the model assortment, which is used to check and report the choice made by the user and whether it is valid. Figure 4 presents a time diagram from the model pricing, which checks whether the model assortment has been successfully passed. The model input coin automation with the time diagram in figure 5, wait for a receive coin signal, then moves the total value to the value of a coin that was accepted. The model select controller presented in figure 6 implement the logic for returning of change. The model program selector presented in time diagram figure 7 is used for select of a specific product. In case the model selection has confirmed that a button has been pressed, the register containing ingredients for each product of additional model pricing also act as input. The model program executor present in figure 8 use the parameter path to its input to execute the identified sequential action. In conclusion, in the future, the vending machine will be increasingly used due to the many advantages, such as low maintenance and costs, offering a wide range in orders. A block diagram for a type of vending machine for coffee and hot drink is being presented and discussed. On this basis, the proposed architecture and developed control algorithm are described. Some simulation results of the different models are shown and discussed, and the result of the research can be applied to other types of vending machine. Thank you for your attention.
Thank you for your presentation. Dear participant, do you have any question about this study? Okay, no question. Thank you again. I wish you success in your career.
Thank you.
Okay. Dear Korhan Cengiz, are you ready? Dear Ivan Dochev, are you ready? Dear Thomas Brown. Dear Thomas
sorry.
Brown. Okay.
So I'm Ivan.
Okay, you can start. Okay. Okay, you can start.
Thanks. Give me just a
Here,
second.
Ivan Dochiev, you can start.
Okay. Hello. My name is Ivan, and my project is about the cybersecurity impact of the energy system. In the next few minutes, we're going to talk about the cyber terrorism, the type of attacks that could cause, let's say, damages on the energy sector, and how this sector take its place in this situation. Okay, so let's take a few minutes just to talk about the cyber terrorism. This is a phenomenon that, let's say, gives the usage of internet for bad purposes. This is not cost any, let's say, human casualties, but the damage that could cause could affect a lot of human lives. And depending on the, let's say, the scope of the attack and how massive this is, in this slide I show some of the, let's say, the basic type of this cyber terrorism. So we have basic, advanced, and the complex. Okay, so in this slide, let's take a few minutes just to talk about one of the main cyber attacks. The first one is about the this ransomware attack, which the main purpose is to, let's say, attack like a device or machine. After it, encrypt the data in this machine, and when the user would like to use it again, he or she just need to pay the price for it. The second one is about the man in the middle. This attack is, this type is just to collect like user credentials, account information, and use it for bad purposes. The next one is DDoS attack. This one is a little bit complicated due to the fact that the target could be like weak environments or networks. And after this attack, these sources become unusable for the users. Okay, so the next one is about the cross-site. About this one, I use the example of the JavaScript. So basically you receive infected software, which when you install on your machine, it starts costing damages. And you need what to do is just to use like, let's say, confirm software, not to download any suspicious type of it. And the last one is about the phishing attack, which is very popular. The idea here is the user are receiving a fake email, and it is prompt to enter like account information, credentials, or stuff like this. And after that, the account become compromised and is getting some annoying damage on the user. Okay, so given the fact that a lot of companies, business, and also government sector are targets of such kind of attack, it is important to work with high priority how to prevent such events. Most of the times these sectors are having like, let's say, security department that take care of the protection and implement the high technology in order to avoid such events. In this slide here, I show some of the, let's say, the basic examples like two-factor authentication and the very familiar firewall system that could be used in mainly for the network purposes. Okay, so now let's take a look how the energy sector take its place in the whole situation. Here it is important to mention that not only the human factor could be reason for such let's say, bad situation, and also the climate emergency. So what I decided to explain here is based on the one of the research back into the 2020 when we all work remotely. There is a, how can I say, statement that more than 20.4 billion devices that are using internet, and around 37% of them was set up without user settings, which means that these devices are potential targets for cyber attacks. And due to the fact that this is very, very serious situation, till this moment, not every sector pay attention on this. Also, there is we have information that the European energy sector was target of cyber attacks, and for this reason, the new technology are very important to take place. So, like example, I can give you the, let's say, the communication protocols that are using in the 5G, M2M protocol, and all these, let's say, advantages could be used in order to prevent from cyber attacks. So most of the times, as I mentioned earlier, we have security departments. The target of these departments is to be unknown of the new technologies, how to implement it, how to educate, let's say, the staff that work into the energy sector or any other sector, no matter if we're talking about the government or business companies or any stuff like this. Okay, so just to mention, the whole idea of this research was to give you the idea of the cyber attacks, how we can prevent them, and how the new technologies could be implemented in order to make the security which is responsible of all of us. Okay, so thank you very much for your attention, and if you have any questions, just let me know.
Thank you for your presentation. Dear participants, do you have any question about this study? Okay, thank you again. I wish you success in your career.
Thank you.
Next paper belongs to dear Thomas Brom. Dear Thomas Brom, are you ready to present? Okay, not online. Dear Nayef Sami, Nayef Al-Dabbak, are you ready to present?
Thank you. Start. Okay.
Okay, you can start your presentation. Thomas Brom. Okay.
Yeah.
You have 10 minutes, please. You can start your presentation. Dear, we can't hear you.
Thomas Brom.
Yes, we
Me
can
or
hear
Thomas?
now.
Better now?
We can
Is it-
hear now. Okay.
Okay.
Okay, I am sorry. We prepared, my name is Tomáš Brom, and we prepared the article with our colleagues, cost-related industrial project design using simulation layout design and ERP system. In the presentation, I would like to concentrate firstly on the cost, on the software used, also mentioning the goals. Then we will concentrate also on the ERP system used, simulation software, layout, design tool, how it can be connected. And then we will go back to the ERP system that will take all of the data. And then the conclusion and then the end of the presentation. So firstly, the cost determination in Industry 4.0 software. So basically in Industry 4.0 concept, it can be supported, it can support, or it can incorporate a large amount of specialized software, simulation and visualization software, ERP system, predictive system, artificial intelligence system, and much more. And every system, also it depends if it works with the costs or not. We are considering the systems that works with the system, and each of this system can approach the cost in a different way, and it works with the different costs and looks on the cost from the different perspectives. The software we have available and that we used was the ERP system Helios Inuvio. It is originally the Czech ERP system, and currently is international. Then we used the Technomatics plant simulation, and for the layout design we used the Vistable software. And the goal of the article was to show and to emphasize the synergy of these tools, mainly in the cost way, that the link in the cost data and using it to the synergy. So in general, this ERP system Helios Inuvio is the classical ERP system. For sure, to calculate the cost, you need to first input the basic data. You need to also input all of the materials, all of the work places, all of the processes, and link it to the specific costs. And firstly, with the start of the design of the project of the production system, it's great to use the simulation tool. We are concentrating on the Technomatics plant simulation tool that has also the basic functionality for the cost analysis. And this simulation tool, it incorporates the investment cost of the machine, operating costs, depreciating period, cost of used inputs, but it don't concentrate on the cost of the work, cost of the transporters, etc. So we will have, by the simulation of the production, we will have the basic cost data, and also we have the basic production data that can be used afterwards. By this basic data, we are concentrated on making the layout of the production system. That can be done for sure by in the classical way by the paper, but in the modern way by the using of a specialized software tool. So in this case, we used the software tool Vistable, and this tool also can calculate with costs, but it concentrates mostly on the manipulation costs. So you are putting also the inputs from the or the same data like to the simulation tool, but the output you will get are the mostly manipulation costs or the costs linked to the manipulation. And then the data from this simulation, from the layout, you can with advantage put to the ERP system, and to have the most to have the how to say, more to have the better results of the ERP output. And for sure, if you want then to change something, you can again use the same cycle that from the simulation you get the data to the layout and back to the ERP. So the conclusion. In the conclusion, we show the simple approach for the cost control using the for us the available software tools, Technomatics Plant Simulation, Vistable, and also we use this data to the ERP system. And for sure, each system, each software tool concentrates on the different approach. It works with little different costs. And yes, the overall output is then inserted to the ERP system, and the result that can help to have the project costs more detailedly specified can be obtained. And yes, the biggest concentration, as I mentioned in the beginning of the paper, was concentrated on the synergy of these tools. So that's all. Thank you for your attention. And for sure, if you have any questions, do not hesitate to ask.
Thank you for your presentation. Dear participants, do you have any question about this study? Okay, no question. Thank you again. I wish you success
Thank you.
in your study. Next study belongs to dear Nayev, Sami Nayev, Aldabak.
Yes,
Okay, you can start if you are ready.
thank you, thank you.
You have 10 minutes, please.
Yeah. Our study is forecasting annual solar power output from geographic location. Researchers Naif Sami, Sora Sadi, and Dr. Zaid Hamudak. As you know, with the dwindling fossil fuel resources, the research in renewable energy is gained significant importance. The leading source for renewable energy is the solar power generation, mainly through photovoltaic cell. As you know, the photovoltaic cells are major source for future energy generation. But this have a limitation or a difficulties or discrepancy due to depending on weather conditions. Since the photovoltaic cells generate electricity by converting solar energy to electric current. The main parameter is the amount of electricity produced which depend on solar irradiance in a particular day. This depends on various parameters such as the location, time, weather parameters, temperature, wind, and other parameters. As you know, the solar irradiance is defined as the power per unit area received from the sun in the form of electromagnetic radiation in the wavelength range of the solar cell. So the weather conditions reflects directly to the power generation. I will talk fast in order to save time, since it is 10 minutes, which is a short time. Yeah. The main of this research is the design for forecasting And the different algorithm used is the design for forecasting, and the second is the identification of the qualification of the effect of parameters on forecast. In this paper, we attempt to improve the state of art in both dimensions. The main parameters in this study was the direct normal radiance, which is the amount of radiation that travels directly from the sun to the earth, and the diffused horizontal radiance, which is DHI, which is known as the amount of radiation that reflects of particular in the air before hitting the surface of the earth. Diffused radiation is therefore higher in places with more cloud over or more dust in the air to block or the travel of the sunlight of the earth. The model selection used in this study was random forecast regression model, which has several benefits in this context. It is non-parametric model, which means it can predict variable that is normally distributed. The main conclusion from our study was that, as you know, over the past 10 years, the installation cost for solar energy technology have dropped as astonishing 60%. This form of renewable energy is more accessible now than ever before. The second, if there is a choice between paying to install tracking, more tilt, etc., versus installing additional panels, the additional panel will almost always be the right move. It's better than a tracking or more tilting of the solar panels. Using the machine learning, the model gives highly accurate prediction of the expected return of energy generated by prospective solar panels. The fourth of the conclusion, using random forest regression method, daily mean solar output generation can yield a promising result rather than conventional NW, which is a numerical weather prediction model for forecasting. The random forecast model outperformed its other rivals and also conventional models, thus providing a better suited model to run with the forecasting. For the future work, as I think the available of the database from solar assessment system will improve the model production, since it depends on environmental parameters in the location itself. And this was the aim of the future work. Also, the numerical weather prediction modeling is used to get clean lens drive of solar panels, as solar panels need regular washing, especially in desert earth. It will decrease human intervention in mundane jobs and increase efficiency of the whole solar PV systems. And we hope this will be held in our future work to improve our model production. Thank you for your attentions, and we are ready to receive all questions.
Thank you for your presentation. Dear participant, do you have any question about this study? Okay, no question. Thank you again. I wish you success
Thank you very
Study.
much. Thank you.
Okay. Dear Kirota Georges Yalda, are you ready to present?
Sorry, I will present instead. I am the co-author of the paper.
Okay.
Sorry. My name is Diyar. I am the co-author of the paper in survey of software-defined SD1.
You have 10 minutes, please.
Okay. Can you see my screen now?
Yes.
Okay. Today I'm talking about the introduction of SDN and SD1. After that, I will specify information about OpenFlow, what is OpenFlow, and in general, what is SD1 and SD1 fundamentals, how it works, and what is the advantage of this subject. Firstly, the popular subject in the circle of communication technology is software-defined networking. Many researchers have been running in this area. However, implementation of test-bed results is very hard. That's why some of this actual research works just to provide theoretical software-defined networking. New researchers illustrate that software-defined ones improve quality of service and network control and connect branch officers to main group network, or connect data centers isolated by intervals. In this study, we come to an overview of software-defined wide area network and how it's working. A qualitative comparison in terms of features such as virtualization and programmability, as well as software-defined wide area network. Benefit from internet test-bed wide area networks to enable multi-service network and VPN services. As per analyze, the SD1 market is predicted to grow 8 times by 2021. The main idea of SDN is separating the control plan with the data plan. That is mean the control plan acts like guidance and it is at the brain of software programmable network. At the same time, data plan consists of network devices that have the ability to forwarding packets based on forwarding tables. By using SD1, the deployed device at each branch has responsibility to connect the branch to any selected access method. You have internet connections, access methods, private links access method, or maybe the device of both of them. In this slide, I will show you what is the main idea of SDN. SDN was, as I said, separating control plan from data plan. For example, in traditional network, all devices have all of plans in the same device. In SDN, there is separation between of them. For example, we have a controller, this is control plan, and we have devices and the network topology. For example, RASA won't send a packet to LASA. Firstly, the packet will receive with the first switch. Then the switch will connect with the controller. Then controller have the RASA's code. Then controller will decide which path this packet should be through. Then the packet will receive from RASA to LASA. This is the main idea of SDN. SD1 architecture with OpenFlow protocols enables network operates to create flows in the final way compared to the traditional networks by means of controllers. In traditional network, flows or packets are mainly treated based on single or a few attribute combinations, such as longest destination IP prefixes, destination MAC addresses, or combination of IP address and TCP/UDP ports number, and SDN allow us to manage flow based on more attributes. SD-WAN supports numerous transitions of authorized traffic load sharing among multiple WANs connections for simple one destination. By using SD-WAN, the deployed devices such as a device at each branch has responsibility to connect the branch to any selected access method. We have internet connections access method, private links access method, or maybe the devices both of them. What is the fundamental of SD-WAN? The fundamental of SD-WAN architecture reduced network, and the expression SD-WAN represents a subset technology of software-defined networking SDN. Omitting to configure each network device is the target of SDN, and by separating the operation of this device, SDN achieved this goal. By using SD-WAN, the deployed device, each branch, has responsibility to connect, select, access the method. What is the advantage of SD-WAN? As I said, the SDN is new subject in the network area, and lots of research couldn't prove practically what is SD-WAN, but there is many advantage of SD-WAN, like reduced network costs due to less hardware requirements and operational, and the second, increased speed by amplified management and not sublink, more security and visibility by deep analytics and troubleshooting implementation, unlimited availability and simplified and faster failure, better fly network performance and bandwidth. How does SD-WAN work? There are multiple features that distinguish the SD-WANs. First one is centralized network. The main medium of control in SD-WAN is centralized, frequently located in SaaS application, which is run on public cloud. To create a simple network management environment and make a better submission of service, the control is separated from the hardware. The central controller offers the rules and instructions the SD-WAN devices. And the second one is multi-connection and multi-transport. In SD-WAN, it is possible for each gateway to have several connections using different transporters. Broadband internet, LTE, it means that SD-WAN gateways support hybrid WAN. To make the WAN connection more secure, usually a virtual private network VPN sets up across each connection. The third one is dynamic path selection. Dynamic path selections is another characteristic of SD-WAN. The capability to automatically direct traffic onto a specific WAN connection according to the network or traffic conditions. The fourth one is policy-based management, where the dynamic route selection directs traffic and what priority level it is given in specified by policy. Business aims can be implemented as policies through the central management console. The last one is service training. An extra specification of SD-WAN is the capability to link with other network services. One optimization is frequently combined with SD-WAN to aim the performance of application and network. Internet traffic, abandoning and entering a branch office, perhaps directed through the VPN to cloud-based security service to create a balance between cost, security, and performance. At the end, software-defined wide area network is worth study, and it is of very high significance for the future generation wide area network. We are aware in this fact that policy-based management is the main leading power in SD-WAN state. These policies are critical in the path determination and have the capability to divert and direct traffic according to priorities such as quality service that it carries. In this presentation, I present the SD-WAN architecture and their features with fundamental differences, comparison and classification. The next generation of wide area network is considered as promising of the software-defined wide area network. Thank you very much. I am ready if there is misunderstood or questions.
Thank you for your presentation. Dear participant, do you have any question about this study? Okay, no questions. Thank you again. I wish you success.
Thank you very much.
Dear Ate Buja, are you ready to present?
Yes, I am.
Okay, you can start if you want. You have 10 minutes, please.
Yes. Please, Jamal, stop sharing because I cannot.
Okay, sorry.
Okay.
Are you seeing? Yes?
Yes.
Okay. So, hi, I'm Adley. Let me present today our paper and with the title of Cybersecurity Standards for the Industrial Internet of Things, a systematic review. Researchers are me, Adley Buja, Marika Apostolova, Artan Luma, and Ilber Januzaj. Today's agenda of the content presentation is as it follows. From the research field, aim of the research questions and methodology used through this research, findings and discussion, and at the end, conclusions. As for the research fields, we were focused on providing a solution, a model of cybersecurity standards for industrial IoT devices, with the aim of supporting advance of the security on industrial organizations and its sectors within Industry 4.0. The context of the coming fourth industrial revolution, as we call it, Industry 4.0, can be used to make an essential transformation of cyber-physical systems, as we know, CPS, and production processes by using big data and analytics. A new coming concept and technology is a digital twin, which is exactly a visual representation of a physical thing, object, is updated from real-time data and uses simulations to help decision-making. Since global pandemic COVID-19, cyber threats and cyber attacks are increased and targeting industrial infrastructure and their data. They have impacted across some sectors in the industry, like supply chain and logistics, e-commerce, travel, and other critical industrial infrastructure. For the aim of the research, as I said, we were focused in protection of cybersecurity of industrial IoT. Our objectives within the study remain to improve security in order to prevent threats in case of any event of cyber attacks happens at the industrial infrastructure, more exactly on IIoT. Industrial IoT are applicable on different industrial sectors, and those can be oil and gas refineries, smart city, manufacturing, aerospace, and so on. In our research, we have defined our research questions like this, according to the research field and the aim of it. What are the current research studies related to cybersecurity countermeasurements, vulnerabilities, threats, and its limitations in industrial Internet of Things? We were trying to see more further in depth what are the current actual solutions provided for this matter future. As for the research methodology, we have used a systematic literature review to collect and process data, and this was conducted on research papers, also on the latest industrial and technological trends. And in the last 5 years, we have looked up from 4 different scientific databases. Continuing on the research methodology, after a collection of data, processing of it, data extraction and checking has been done to the articles to find the information. We have selected a number of relevant papers, which were 47 of them. Coming up to the findings and discussion after our research and review what is provided as a solution or as a model regarding to the cybersecurity industrial IoT protection, we have answered our research questions, and we found that traditional security still in function out there. What we mean with that, like CIA Triad, AAA, antiviruses, firewalls, and anti-malware programs are in use there in the industrial organizations and companies as a protection, which we all know from our experience in the last year, a case of Pipeline in the United States. They had a big major cyber attack. And we have seen that none of this has been doing and serve as a protection of that industrial sector. Industrial IoT collects industrial data and cyber threats, and cyber attacks are on the rise by targeting those industrial infrastructure. And not commonly used cyber attacks are used against those industrial sectors, but like malicious code, DDoS attacks, APTs, and sniffing. Those are the highest and advanced techniques and methods used by hackers or organizations like APTs targeting the industrial sectors with a cyber attack. It is an urgent need for a model of cybersecurity standards for industrial IoT in order to prevent cyber attacks and provide industrial safety. As a conclusion, there are emerging technologies which are bringing a new security issues. Our study contributes to define the model of cybersecurity standards for the industrial IoT, which can be applicable and deployed in all industrial environment with the main aim and focus to prevent threats and cyber attacks. Not just having a proactive approach, including detection, identification, prevention from cyber attacks and threats, but needs to have more a kind of new approach, more than proactive, that will protect those industrial infrastructure. In our following research simulation, we will be conducted in a virtual environment of industrial IoT by simulating different industrial cyber attacks to the model that we think will be the new and novel approach of the model by protecting industrial IoT. As I said, our following research will be on advancing this model to be used for industrial safety in various different critical events by using a simulation environments exactly as it is in industrial IoT. And we will come up and through an evaluation and compare the results of it and present it to the scientific. That was from me. Thank you. If you have any question, please.
Thank you for your presentation. Dear participant, do you have any question? Okay, no question. Thank you again. I wish you success in your career.
Thank you.
Yes, the first session is over. Dear participants, thank you for your attending. I would like to end the session. I suggest you to attend the next session, which will start shortly at 1:30. See you in the next session. Goodbye.
Goodbye.